record button because I'm going to record this. Sometimes you can see things on Rick Crosslin Science YouTube. That's always fun. There's a couple rules though. Let me put my phone down. We have a couple rules. The first rule is don't try these things at home, okay? And don't go to someone's house and try them. The second rule is there's a couple times there's going to be loud noises. I will tell you, don't worry. If I say cover your ears, okay? And here's my test. If this happens, if you see this, I can't help you. Just run if you see a dinosaur. Just run. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That took 11 seconds. If we get to 30, I have to stop. So we got to get quiet quick. We have to. So why do I love science? I love science. I love kids, and I love science because science helps us humans fix things. Medicine, food, the world. That's how we fix science. And also, I have lots of questions about how things work, nature. And that's why I like science. For example, some kind of science, you see some different signs here. This science is about sound. Over here is going to be about energy. This is about electromagnetic, which is electricity and magnets. Liquid nitrogen, which is going to be amazing. Air pressure and chemical changes. There's lots of science, but that's the stuff I brought today. Now, energy is what you need to do work. For example, a battery has energy. And think about this. If you have a piece of wood, and if you burn that wood, it transfers heat and light energy. And inside of your belly from lunch is food. And that food gives you energy. Those are chemicals inside of your belly. So if you look at like this, let's see right here. We need a candle for our show. And so I have some energy in that fuel. And now, that's transferring right now to light energy, because you can see it. No sound energy, but it is hot, so that's heat energy. So, let me show you what I mean. I have over here, this balloon has no energy. But because in my belly is food, that food came from the sun, I'm going to transfer sun to food in my belly. I'm moving, I'm talking, that's sound energy, and I'm hot, that's heat energy. But here, everybody say no energy. No energy. Now I'm going to give it what's called potential energy. This is like a battery. You have to stay seated. So now it has a type of energy called potential energy. Potential is like a battery. When I let go of it, it's going to change to kinetic energy. So everybody say no energy. No energy. Potential energy. And on the count of 3, it's going to change to sound and movement. We call that kinetic energy. On the count of 3, say kinetic energy. 1, 2, 3. Wow. Wow. Hey, save the clapping till the end. Save the clapping till the end. This here is a big spring. It has, you probably know, no energy, right? No energy. Say no energy. No energy. Now, I'm pretty strong. If I can bend this, I want you to say, ooh, potential energy. Ready? No, I got to bend it. No energy. Potential energy. Now, then I want you to say, kinetic. 1, 2, 3. So, everybody say, no energy. Ooh, potential. 3, 2, 1. Say, kinetic. Well, let's try that one more time. Ready? This is Albert Einstein. He studied energy. Here we go. Ready? Oh man, this is going to be dangerous. Everybody say, no energy. No energy. Remember, you're going to say, potential. 3, 2, 1. You know what to say. Whoa. Thank you. Wow. Wow. No. So, I really like how you guys are so quiet over here. So, there was another scientist, and he studied. All right, I'm going to go back over. You have to listen. There was another scientist. His name was Isaac Newton, and he studied this. One day, in his yard, he saw this happen. And he wrote in his book, he wrote, why does an apple fall down? Why doesn't it stay in the air? Why doesn't it go up or sideways? And he thought, maybe there's an invisible force that pulls it down. And he called that force gravity. Gravity. So things go down, but I want to show you something. This is so weird. Maybe you guys can help me with this. I'm going to drop this, but something weird happens. Watch carefully. Maybe you can figure it out. I don't know. Gravity pulls it down, but watch what happens to the beads. Here we go. Use your science eyes. I don't know. Hey. I don't know. So, you know, if you touch your forehead, you can feel warm because that's heat energy. Now, usually you have a thermometer, but this is my Dr. Seuss thermometer. This red liquid, if it gets hot, it does this. It expands. If it gets cold, here's a new word, it contracts. What is this? And what is this? Contract. So I'm going to put my hot hand and let's see what happens to that. And then I'm going to let go and let it get cold again. And when I let go, it contracts and goes down maybe. So when things get hot, they expand and go up. And when things get cold, they contract and get small. Watch this again. Well, that's like I call that a Dr. Seuss thermometer. So it's the same stuff that's in thermometers. But sometimes you have a piece of paper, and if I tear this paper, it's still paper. We call that, here's a cool thing about science, we call that a physical change. Physical change, it's still paper. If I wad it up, is that a chemical change or a physical? It's still paper. It's physical, it's still paper. If I tear it or wad it up, what if I do this to it? Is that chemical or physical? That is chemical. Look, it is no longer paper. It's turning to heat. It's turning to light. It's turning to ash. That is a chemical change. A chemical change. And let's see here. We could try something. Would you come here, my volunteer? Thank you. Yes, thank you. You're very brave. Step around here. Okay, you're fine. Hold this paper for me. I like your shirt. I love dinosaurs. Scientists study dinosaurs. Hold this like that. So I have here, oh my goodness, these are cannonballs. And they are very, be careful. They're very heavy. Hold that up like that. And I'm going to bring these together and see if there's any energy transfer. Oh, I bet you hear something. Would you smell that? Hold that up, smell that. What does it smell like? Does it smell like cheese? Does it smell like fire? Hold it up again, watch. When I bring this together, it transfers the energy for sound and heat. It's so hot that it burns a hole in the paper. Now, you're doing great. Here. Put these on. Put those on. We're going to try something. Okay, stand right about there. There we go. All right. If you are watching, you notice that I am putting aluminum, that's another element, around this iron cannonball. And now we're going to see if we can make something else. Are you ready? Come closer, right over here. I'm going to hold on to you. Now you tell me if you see anything. You're very brave. You all right? Do you have insurance? Okay, here we go. Let's see what happens. It's going to be amazing. A chemical change. What did you see? Fire. You want to do it again? Here we go. Ready? Here, I'll give you this. Give me the goggles, please. Can I have the goggles? Take the goggles off. Thank you. Here, you keep that, and you can keep this right here. Here you go. Let's give my friend a round of applause. Have a seat. Have a seat. Now, that was a very beautiful chemical change. And it was just a little bit of sparks. And I'm going to show you another one, though. Thank you. I have here some small rocks, but these are special rocks. In fact, these rocks, use your eyes. This is not going to be loud, but it's going to be cool. It's not going to be scary. I don't know. I got my lighter and nothing happens. But this is called calcium carbide. It's a special rock. If I add water to it, something amazing happens. Watch. It makes bubbles, and these bubbles are called acetylene. Ready? Not loud, but cool. Wow. All I did, wow. Thank you. Let's put some in here. Are you ready? Let's put some in here. And this is going to be a quick chemical change. It's also going to be a loud one. I'll tell you when. Ready? Here's my lovely sock. I love this sock. It smells so nice. Yeah. Ready? Okay, here we go. I got that. 3, 2, 1. Wait a minute, I put the chemical in there. I put the sock in there. 1, 2, 3. What did I forget? Water. I forgot the water. Cover your ears. Everybody, cover your ears. Cover your ears. Cover your ears. 3, 2, 1. Thank you, thank you, thank you, thank you. So that was a very, very quick. See, the food inside your belly is kind of a normal chemical reaction. The rust on that cannonball is slow. This explosion is going to be fast because I'm going to put some fuel in here, but already it has air in there. I'm going to put the fuel in the air and I'm going to light it with this. Here we go. This will be loud. 1, 2, and maybe a little extra. Cover your ears. Cover your ears. This is going to be a loud and quick. Are you ready? Yeah! This is science. It's a quick, loud, chemical reaction. 3, 2, 1. Wow! Whoa! Thank you. Whoa! That was loud. Hold that with 2 hands. Hold it tight. So, we've been talking about, my friend is holding that tight. Try not to move. Sound, you heard some loud sound. Now sound travels through the air. Sound is vibration. Take your hand and say, sound is vibration. You can feel your fingers. Sound is like this. Are you ready, friend? When I say hello, sound goes through the air like this. Ready? Hello. You see how it goes? Back up, back up. Back up. Walk, walk, walk. Now this time you hit it and say hello. Hit it with your hand. With your hand. Hit it with one hand. Like this. Ready? Hello. You do it. You do it. Hit it with your hand. Whoa. That was loud. That was so loud. Ready? Hello. You do it. What's going to happen if we do it at the same time? Ready? Let's do it at the same time. 1, 2, 3. Hello. All right, hold it tight. 2 hands. Just hold it. This is a model of a sound wave. This is a slow wave. In fact, oh, boys and girls, look here. This man right here, his name was Heinrich Hertz. He measured sound. This is a low sound. Just try to hold it. That's a low sound. Woo, woo. This is a high sound. Woo. This is a high sound. Ready? Woo. Yeah, can you see the different waves? Okay, this is a low sound. Ready? This is a low sound. Woo, woo. This is a high sound. Okay, you're doing great. Stay right here. All right. So I have 3 bottles here, right? Which bottle has the big air? Which is the one that's almost all air? No, that's a little, yeah, that one. So use your thumb. That should be a low sound. Make a thumb go down. There's the low sound. This one's little, make it go up. Go like, don't get your thumb stuck. Can you go like this, like this? This one is high. Let's try it. Ready? You guys, here's a low one. Show me with your thumb, low sound. This one's high. Show me with your thumb a high sound. What about this one? Middle. I get dizzy. Would you catch me if I fall?
Nope.
No! She won't catch me if I fall. All right, I might fall on you then. Let's try this. That same thing works. Big thing. Maybe that's true. You are very brave. You didn't even jump when I did that. This is hot. Hot things expand and go up. Cold things contract and go small, right? You're with me on this, right? Okay. We're going to try something. I have a pipe here. This pipe is going to get hot, I think. Look inside. Oh, come and stand on this side of me. Right there is good. If I hand you this, will you hold it by the blue? Let's practice. Ready? 2 hands. Thank you. Let's do it one more time. Ready? 2 hands. Thank you. One more time. Ready? 2 hands. Thank you. Watch. Now, when it's sideways, it doesn't make much noise, but I think it's getting hot. Is it getting hot inside? But watch what happens when I turn it up. Are you ready? You ready? Hold that. Let's do it again. Here we go. Is it getting hot? Here we go. I'm going to make it go up and it's going to be longer. Here we go. Ready? Hold that. Hold that. That is amazing. You did great. Stay here. Wait, one more thing. Do you want to do one more? You want to do one more? Okay. So when I hit this, it vibrates. But when I move it over to her, she's going to put her hands on it, and I bet it stops vibrating, and I bet it stops making sound. Let's see if it happens. Did you feel it buzz? But when I bought this, the man I bought it from, he went like this. He had a long beard and a big turban. It was in a country called India. And I went like that. And he went, no, use your ears. If you hear this, give me a thumbs up. Wait, I'm not going to hit it.
Oh, I can hear it. Why would I be doing that?
I did that just by rubbing it. So, I need you. You're doing great. I'm going to try something. Here we go. All right, you over here with me? Would you hold that with 2 hands? This is a tuning fork. If I hit it, it's going to vibrate. Listen. Now you can't, maybe you can see it. Be still.
Yep.
Did I get you? Would you like to be the first kid in the whole world to see sound? Yes. Okay, hold that out. We are going to see if she can see sound vibration. Are you ready? Hold it tight. She's very brave. Here we go. I'm going to hit it. I'm going to put it in the water and we'll see what happens. Are you ready? Okay, yep. You're very brave. Here we go. see. Should we do it again? We do it again? Okay, here we go. We're going to do it again. Here we go. So brave. Here we go. Oh, you're not looking. How come you're not looking? Okay, put it by my face. Put it by my face. Here we go. I hate this part. Here we go. That should have been you. Let's give her a round of applause. Thank you. Have a seat. Thank you. Okay. Boys and girls, science people don't stomp their feet, but they use their eyes and their ears and they see cool things happening. That was a pretty amazing. I want to show you something else that's amazing. It has to do with electricity. Now, this is a light bulb. And there was a famous scientist, his name was Thomas Edison. He did not invent the light bulb, but he made it better. And he messed up 1,000 times. He kept trying to make it work. And when it finally worked, someone said, "Hey, did you mess up 1,000 times?" And he said, "No, I know 999 things that don't work." So he made the light bulb, and because of that, we have lights at night. Now another scientist, his name is Michael Faraday. He's in the middle right there. He invented this, and I went to his laboratory. This thing right here is a magnet, and he was spinning wires inside of it, and weird things were happening. He didn't know what they were. We know that it's called electricity. Those lights up there, they are shining light because in Indianapolis, they're burning coal, they're boiling water, the steam is turning something like this, and now we have transfer electricity. But this also sends electricity through here. And I don't want anybody to get shocked on there, but I wonder, does electricity go through people? Let's do an experiment and find out. So, would you come here and would you come here? Okay, my two friends here, just two. Okay, come on, you stand on this side. So, we want to know if electricity goes through us or not. What do you think? Don't know? What do you think? Yes, no, you don't know. I don't know. Okay, hold that one with this hand right there. Hold it tight. Hold it with this hand. Okay. All right, this is an energy tube, and I'm going to hold it. Get closer to me. Let's see if it has plastic, which is an insulator. It has metal, which is a conductor, like a wire. Let's grab it by the other hand. Take your other hand and grab the end. Hold it up. Hold it up. Here, you do this one. Let go. Do that one. Hold it up. Open one. Open one. That's called an open circuit. Close it. That's called a closed circuit. Open. Close it. Does electricity go through us? Yes. In fact, we can prove it one more time. Let me hold this. Let me hold this. Keep holding that. Hold it tight. Why isn't it working? Is the circuit open or closed? Hey, take your no. Hold on to that. Take your finger, point it in the air. Point that finger in the air. Point that finger in the air. Now, if we were connected, it would make electricity. Go ahead and touch my nose. Go ahead and touch my nose. Don't put your finger in my nose. That's gross. Ready? Touch my nose. You too. What? Do it again. Do it again. Ready? Let's give him a round of applause. Thank you. Have a seat, guys. Have a seat. Good job. Good job. I hope that proves to you that electricity goes through people. You want to be careful around electricity. You don't want to touch metal or wires. You know, there was one man, though, his name was Tesla. And Tesla, here's a picture of him. He didn't want wires in your house. He wanted one of these. It's called a Tesla coil. And so instead of having wires, he wanted to put one of these in your house, and it sends electricity through the air. Ready? Watch. Right through the air. Can you see that? Look. Yes, it hurts a little bit. So I don't think I want electricity going through the air. That's called lightning. And we should try something. Ready? So, in here, this is like what's inside of the engine of your car. There's a cylinder and there's fuel, but I'm going to pour out the fuel because I don't want the fuel. I just want the air. And also there's a metal screw, 2 screws with a gap. They don't touch. They don't touch. So metal is good for electricity, but they're not touching. So if I put electricity here, it's going to go through, jump the gap and go here, but it's going to set this on fire. This is not loud, but it is cool. If it goes towards you, don't touch it. This is Tesla, his coil, and you're going to see something amazing. Are you ready? Yeah. Be ready. Watch. Should we do it? Yeah. I get so afraid when I do this. Okay. All right, here we go. 3, 2, 1. Wow. That's cool. That was cool. Thank you, thank you. Thank you for volunteering. You, and you. Thank you. Takes courage to volunteer. All 3 of you. Thank you. I appreciate that. And one more volunteer. Oh, thanks. Thank you. You, yes. Here you go. Here. Here's yours. There's 2 there. Hold that. Thanks for volunteering. Here's yours. Thanks for volunteering. Put your hold the thumb down. There, get one there. You thought you were going to get out of here, didn't you?
I mean, maybe.
thumb down. There you go. Spread out. Quiet, please. Now, my friends here, have you ever done this before?
No.
So we're going to study some science, how things move. There's some rules. Number 1, don't hit your foot or your head, and don't hit me. The kids I don't care about, okay? Are you ready? Swing it around with that. Where's the cup? We lost the cup already. Wait a minute. Will you practice without a cup? Maybe it's better without a cup. We'll try. Here we go. All right, swing it around. Quiet, concentrate. 4 or 5 times or more. Stopping's the hard part. Oh, it's got to go all the way around, not just like that. Wait. Something's wrong here. They're not supposed to fall off. Let's try this. All right.
Mine didn't fall off.
I know. You're lucky. All right. Good luck. Get closer to the kids. Here we go. Spread out a little bit. Are you ready? Get set. Oh, you're going to hit me. Go. Yes. Round of applause. Thank you. See if you can stop it. Nice shot. Nice one. Put him back over here. Thank you. Good job. Thanks for volunteering. Three, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14. Guys, we're at 20. If we get to 30, I have to stop. So that was electricity, and we did some moving, we did chemical, we did sound. I love doing things with air. Air is all around us. At first, people thought it was just the same. There was good air and bad air, but now scientists know there's gases. Now, when I blow across this strip of paper, the scientist right there in the middle, his name is Daniel Bernoulli. He discovered something. He said, when you blow air fast, it's less pressure, and the rest of the sky might do something to this paper. It could go down, stay the same, or go up. Show me with your thumb your prediction. Let's see. You can test this back in the room. Ready? It went up. And what made it go up was the pressure inside of our room. Now, it's kind of hard to see pressure, but I can try it with this. Hold that. All right, my friend, throw that up and catch it. Try again. You did not so hard. You don't have to throw it 1,000 feet. Try it again. Ready? Just throw it a little bit and catch it. Easy. There you go. Now, throw it up one more time. And when she throws it up, she's using her muscles. What makes it come back down? Gravity. Throw it up high and let it fall. Gravity made it come down. Go ahead and get it for me. This time, instead of gravity, I'm going to use air pressure. What do you think is going to happen? Throw it on top of this. Up, throw it up, up. Whoa, are you ready? Catch it. There you go. What? Let's try it again. Ready? Gotta throw it up, throw it up. You got it, throw it up. Up, up. So, when we throw it, boys, we're gonna do something that's pretty amazing. You've done a great job. Step back a little bit, and when it goes up, I want you to catch it, or maybe not, because that was up and down. I'm going to do something that's amazing. Ready? Here we go. Are you ready? Watch. Ready? Why doesn't it fall? That's amazing. Nice job, nice job. Thank you. Have a seat. You did great. Thank you. Have a seat. Did you see how that was sideways? And because all the air was going around it, that was even less pressure. Now we're going to try something, but I need you to concentrate. We're going to try something. Yeah. You want to try it? Stand right there. Are you ready? Okay. Put your hands out. Now slowly turn, slowly turn. Start going, no, go around like this. Turn around like this. There you go, slow, arms out. Here we go, keep going. Here we go. Keep going. Let's give a round of applause. Thank you. Did you take that all off? Okay, take it all off. Just put it over there. Have a seat. Have a seat. Stay right there. Let's see. Let's see. Oh, there it is. Oh. You know, I'm having a hard time. Maybe this is air pressure. Maybe this is too small. Wait right there. Are you ready? Are you ready? Here we go. Wait, that's hard to see. Let's try something. Maybe we can try something like this. Maybe. We'll have to wait a second till that comes back. In just a minute, we might try this. There we go. Are you ready, friend? Here we go. There we go. One more. Let's give a round of applause. Thank you. You can have a seat now. Have a seat. I might need you later. Now, that was air pressure, and I hope this will work. This is pretty amazing. I hope it works. In science, sometimes you try things, sometimes they work. I hope this will work. This one's going to do with Bernoulli, but you have to listen carefully. I'm going to turn it on a little bit. But that is too much air. So I'm going to close up some of the air. And I don't know if this will work. Let's see. What? What? That's amazing. More. More. That was pretty cool science, don't you think? That was good science. I would like to show you something over here. You guys have been so quiet. In science, when you see the color of something, you can tell what it is. That candle has carbon in it, so it burns yellow. This is propane, it burns blue. Scientists learned that if you know the color of something when it's on fire, you can tell what it is. Everything has different colors. Maybe when you watch fireworks on the 4th of July, you see different colors. Maybe you see this color. This chemical is called strontium chloride. Now it burns or red? And this one, this is something called copper chloride, and it burns green. You might be able to see that better. You might be able to see that better if I add, this is copper chloride. When you see something burn green, you know it must have this in it, like in the fireworks, or even the Statue of Liberty that's green. This is what it looks like. Oh, wow. Or this. Here's the strontium. Ready? That's amazing. That is amazing. Now, I have here, I have a special container, but I want to pour out the fuel. I don't want any, I just want the air in there. So I have poured out the fuel. This one has a special name. It's called the whoosh bottle. Here, and you need to watch carefully. The whoosh bottle is what happens inside of a jet airplane. It sounds like this. And what's left over is water. In fact, we can do that one more time. I'm going to pour out the water, pour out the fuel, pour out the fuel. Here we go. This is the whoosh bottle. Ready. Don't go out, don't go out, don't go out. Here we go. And listen to it say whoosh. 3, 2, 1. That's amazing. Very amazing. I have 2 more fire things, then we're going to do some ice things. How's our time? How is our time? How much time do we have? How much time do I have?
15 minutes.
Perfect. Okay, so some of the things I tell you kids, most of these I don't want you to try at home. I have special materials, and I've done these for a long time. For example, I would never want you to try one of these. This is, for example, this is some special paper that sometimes I make it, sometimes I buy it. Watch carefully. It's only going to be here for a second. And if it's yellow, that means it has carbon in it. Let's see. Ready? 1, 2, 3. Now, when things get, I'll wait. When things get hot, they expand and go up. I know that. If I put my hand under this fire, no problem. If I put my hand on top, oh, problem. So you're going to see something that's pretty amazing. I'm going to get my hand wet. I have some special stuff here. You don't want to take a bath in this kind of bubble. This kind of bubble is very special. Are you ready? Hot things go up. Whoa. Whoa. You want to do that again? Here we go. Hot things go up. Wow. Round of applause for science. Okay. We have been doing a lot of loud things. We did some things with air pressure. We did some hot things. This is one of my favorite parts of the demonstration, because now we're going to do something so cold you won't believe it. This is not, well, let me just tell you what this is. It's liquid nitrogen. You can't see nitrogen. This is the coldest stuff on planet Earth. Here we go. It is minus 300 degrees below zero. Wow. Now, what you're seeing is not nitrogen. What you're seeing is water in the air, or water in my breath, like this. Now, it looks like it's boiling because it's minus 300 degrees, and this cup is 70 degrees, so it thinks it's really, really hot. Now, I asked you something earlier. I asked you, hot things expand. What do you think is going to happen if I do this? What if I put this in that liquid nitrogen? What is it going to do? Let's find out. Ready? Here we go. Here we go. Is it going to pop? Watch. Oh, wait a minute. Wait. What? It's starting to. It's getting smaller. What? Is the air still in it? The air is still in it. Look, now it's going to warm up. I think it got a hole in it. So, let's do this. Take your hands. This is normal air. This is boiling. This is normal. Boiling. Normal. Liquid nitrogen. The word is contract. Normal. Expand, expand, expand. Normal. Contract. So when I put this in here, is it going to boil or contract? Yes. It contracts. It contracts so much. But then when it gets warm again, it starts to expand, and it expands again. That's pretty amazing. I have here a piece of rubber. This rubber can stretch. It has a property that it's flexible and can stretch. But if you take this into outer space where it's this cold, this rubber changes to something like this. Here's a piece that was in there. You cannot play basketball in outer space. The ball will shrink and it won't bounce. Can I have two more, three people, three. Come here, hey, come here. Come here. Come over here, come here. Here. In a minute, I want you to pick each of you pick two of these up, okay? So, if you notice, that rose is mostly water. I just froze it and this happens. Here, you guys, you take one, hold it like that, hold it like that, hold it like that. Let's go over here. Ready? Hold them up and look that way and squeeze them. Those are frozen roses. That should be a new band, Frozen Roses. Okay, drop those down. Thank you. Let's have a seat. Have a seat. Thanks. We're going to do something. Ready? I've been boiling this water. That water is really going to be hot. I wonder what would happen if we had hot water and we put it in liquid nitrogen. Huh. Here's what might happen. I have to be careful when I put liquid nitrogen. Boys. When I put liquid nitrogen in this container, it's okay unless I put the lid on. If I put the lid on, it gets warm and gets bigger and bigger. Oh. Wow. It gets, here we go, watch. Oh, maybe it won't do it. Gets bigger. Oh. That's not too bad. What would happen if I put some in here and it had a really hard lid? Let's find out. You might have to close your ears. Here we go. I'm going to put a lid on it. I'm going to throw it over there and it should explode really loud. Here we go. No, this one, that one won't, that lid is a bad lid. Let me find a better lid. Ready? Let's try this lid. Here we go. That's a good lid. I don't know, 5, 4, 3. This is very hot. This won't be loud. This one won't be loud. Can you see the steam going up? Hot things expand and go up. Cold things contract. What do you think is going to happen when I put liquid nitrogen in there? Let's find out. Are you ready? This will not be loud, but I'm going to give you a hint. When warm air goes up in the sky, it gets cold and makes a cloud. We are going to make a giant cloud right now. Here we go. Here we go. Are you ready? Boys and girls, if it comes towards you, it's not going to hurt. It's just a cloud. Don't run and watch the camera right there. So be careful. Here we go. 3, 2, 1. Wow. For my last demonstration, we talked about energy. We talked about sound energy. We talked about electricity. We also talked about fire, and we also talked about cold things and clouds. And I have 2 more things to do. This one, I bet you wonder, I'm missing something. But before I do this lady right here, she's kind of my hero. She wanted to know what the universe was made out of. She thought maybe when she studied it, if she looked at the color, and she found out that it's made out of hydrogen. And so I have here 2 balloons that are made out of hydrogen. Hydrogen is light. It floats. It's so light that it floats. There's another gas that's light and floats. This gas is called...
This gas is called helium. They use helium in space because it's so small, it will show if there's a hole in the spacesuit. They also put it in the engine to make sure there's no hole in the engine because it's really small and gets out of everything. Wow. That was weird. That is not helium. Okay. Teachers, close your ears. Everybody, close your ears. This is what the universe is made out of. Hydrogen. Close your ears. Close your ears. Cover your ears. Here we go. Whoa. Wow. One more, here we go. Cover your ears. Cover your ears. Here we go. Wow, that's good. I love science because it serves humanity. Science helps us. It helps us make the world better. It helps us with better crops. It helps with better medicine. And it also, I love science because it helps me figure out the mysteries of life. Why aren't dinosaurs alive? What is the universe made out of? Why do hot things expand and cold things contract? Science helps us do that. Now, I brought a toothbrush and I brought some teeth, but I forgot the toothpaste. We're going to make some elephant toothpaste. Inside of this is some water, some soap, and some food coloring, and a special chemical called, it's a hard word, you could probably say it, catalyst. And this is special stuff. This is called H2O2. Now that's a fancy word for hydrogen peroxide. In your house, you have this, but it's only 3%. This is 35, much stronger. It says H2O2. That's a weird thing. That sounds like H2O, like water. I'm going to put it in here, and it's going to break apart into heat, oxygen, and water. Elephant toothpaste. Here we go. You guys have been amazing. Hey, thank you so much. I love science because science is for everyone to learn. Whoa.